Let's start then. Our next talk is Securing the Kubernetes Supply Chain by Parikshit and Swapnil. They are from Nirmata.
Hello everyone, good morning. This is day 2 of DevOps Day India and we are at the session 2. We're going to be talking about securing the Kubernetes supply chain today. A bit introduction about myself and my colleague here. So my name is Swapnil Babladkar. I'm a customer success engineer here at Nirmata and I have with me Parikshit Samant, who is a principal engineer here at Nirmata. What we basically do here in Nirmata is we develop Kubernetes policy and governance software, and we were also the, we also donated Kubernetes to CNCF. It's incubating today. Kubernetes is one of the leading Kubernetes native policy management engine that is there today. It's probably the most popular one as well. So that's what we are doing here in Nirmata. I'll get around with what basically we'll be talking about. Today is going to be the entire supply chain. Basically, what does a supply chain look like? What does it comprise of when we talk about in terms of Kubernetes, right? What are some cases that we've seen for the supply chain security that have happened in the past? Eventually coming to how do we secure that, because that has become one of the priorities today. There are multiple options that we have of how do we secure them. We'll walk through them. And we also have a very interesting demo planned around this entire supply chain that is going around today. Right? And obviously, we'll also have the Q&A session at the end. So that's about the basic agenda that we have for today. And without wasting any further time, I'm going to get started with the basics of supply chain, right? So let's dig deep into this part specifically, right? So if you can see here, this is the basic, a pipeline that runs for any code when it goes from maybe building it towards deploying it in production. So I'll just maybe give some references around what basically a supply chain is, right? Consider this. If I keep the software or Kubernetes aside for a moment, what basically is a supply chain today? Now, may that be in any food supply chain that we talk about, any manufacturing supply chain that we talk about. It's basically some minor components that come together in an entire process and you have an end product for it. Just to give you a quick analogy, everybody here, at least me, orders food a lot online, right? So I trust these apps that I use because they're telling me that the partner is vaccinated and everything. So there is a trust building that has happened over the time. Along with that, these delivery partners also kind of have some connections with the restaurants, going back till the farmer who kind of has a trust on what he's basically doing. So this in entire supply chain, there is an important aspect that runs through in our day-to-day lives as well, is about trust. So there is a trust that happens at every single aspect of the supply chain, and the end product is what we get out of as an outcome of the entire process, right? In this, we as a consumer have no say or no control on what is happening in the entire supply chain. All we do is we are just the end consumer for it. Now, just to put this analogy in compliance to software, or let's just talk about Kubernetes supply chain here. It's exactly the same that happens today. There is a developer who commits the code or writes the code and commits it into something like a Git today. Then it gets to build using some Jenkins pipelines. Again, a second component for it. Now Jenkins creates all the dependencies together, brings all the dependencies together, and gets it to Docker to package it as a container image, right? Then packaging being one of the components, eventually deploying this to Kubernetes becomes the last aspect of it. And running the app into a cluster is basically our end goal, or a consumer is what we can consider today, right? In all of this chain, if we see, trust becomes an important factor, just as the analogy that I gave. In all of this, securing or talking about the entire supply chain or how do we secure this is all going to be upon trust, right? Now, there are multiple mechanisms of how we can build trust across the supply chain, but a basic idea of what a supply chain looks like is what we have today. So again, along with the code or along with the actual software code that goes along with Git, Jenkins, and the Docker, we also have, today we see a lot of GitOps-based pipelines that are running to deploy Kubernetes resources as well, right? It becomes necessary for us in this entire supply chain to secure even the manifests part of it as well. It's equally important to kind of take care of the manifests as well. So with that, I'll just move on to the next topic regarding, or just setting up a premise of why are we talking about this today, or why it has become so much of importance to talk about supply chain, right? So if you see this graph that is provided by ENSA here today to us, until December 2020, we did not see, it was a lot of sparsity that we see in the supply chain attacks that have happened or were happening, right? Now, because of the usage or because of how people are adopting to maybe Kubernetes or even the entire supply chain or the entire process that goes in, there's a lot of vulnerability attacks that have been opened, and we are kind of vulnerable to all of these processes. So if you see the graph, after the SolarWinds attacks, it has kind of increased. There is a lot of attacks that have happened. Now, there are some figures that are here for our reference to be cautious or be kind of alerted by all of the things happening around. Is it so important today to consider securing the entire supply chain as one of the aspects for us? And to talk about the attacks, now we saw some components of the supply chain, correct? In that, we have some types of vulnerability, types of attacks that can go through, right? Exploit the vulnerabilities in dependencies. Now, this is the very common issues that we see today, where in the entire supply chain, whenever we are packaging some dependencies, there are multiple vulnerabilities that come up, and if we are not taking care of them in a very, structured manner, it becomes very difficult for us to manage it in the production part of it. Eventually coming to the CI/CD systems and tools, even those are some parts, or that's one type of attack that happens in the supply chain part. And lastly, it's nothing but the code or artifact integrity. What is this is where either the image or the basic code that gets deployed is what is vulnerable, or that's where the attack happens, right? So these being the three main types, or the overall covering the entire supply chain. There are some types of attacks, or these are the points where we are going to get the, vulnerability attacks or any kind of attack that will happen in terms of security onto our entire supply chain. Moving on. So we have some interesting use cases or interesting things that have happened in the past. Maybe Parikshit will help us understand exactly what these were.
Yeah. So in the previous lecture also, we did hear about SolarWinds attack, and that's when things really started. Malware sitting inside the software supply chain. So SolarWinds is supposed to monitor software systems, and along with that there is this code which actually sends a lot of information about this software systems outside to hackers, right? So sources, builds and dependencies, and deployment, right? So these supply chain attacks, they're all over the place. So the SolarWinds, SonarQube attacks, they are actually sitting in this build and dependency system. There are these others where the attack has happened, more towards the left-hand side of this sequence. So there was this Google extension, there was this code coverage tool against the source code was changed, and you ended up, sometimes these, what happens might be something very simple. You just get some additional information about the build system. Sometimes you actually get the entire source code out. Sometimes when it is deployed, you get some maybe database passwords out, right? So what can happen could really vary how dangerous it is. But essentially, they all, these are the places where these attacks are kind of introduced. And then towards this right hand side, right, once all is in place, you deploy it, and then the software, compromised software is activated. And now it's not just one or two people who deploy this. Right? Nowadays we know how deployments happen. So somebody pushes something to the registry, and hundreds and thousands of people just sort of do a Docker pull or do a Kubernetes deployment, deploy, and just deploy with that image, right? So it suddenly it's viral, right? So yeah, let's, oops, yeah. So these are the injection points. So we are talking about place where code is submitted. So that commit. So most of us use GitHub, right? So GitHub commit is that hash is a very reliable sort of indicator of what exactly, it doesn't just talk about that particular change, but it also has the sum total of all the changes that have happened to the registry since there's a pretty neat mechanism in which all that thing is structured. Yeah, so submit bad code, the source code's control system could be compromised, when things move out of the source code control system to our build environment, let's say Jenkins, something happens in between. So what you pull is not exactly what is pulled and given as an input to your build infrastructure is not exactly what is there in the SCSS, right? So build systems could be compromised. The tools which are installed on the build server, those could be compromised. The dependencies, right? So we have hundreds of dependencies, all these software tools. So they themselves could be compromised, and again it recursively applies to them also, right? All these principles, right? So they in turn have their own pipelines, and they could be compromised, and then when you, so at any point, right, you push the package to the registry, and that there could be some problem there. So when you run your Docker push, something interesting is injected into that Docker push command itself. So and finally, everything is fine, but then you run wrong image, right? You give, I don't know, you misspell something, or version 1 instead of version 0.1 you give 0.2, and things really start, all this hard work done, it really is of no use there. So so how do you, so basically securing this chain is important, and we need to really plug in all these holes. So traditionally with security, the approach has been, okay, you're coming from this network, this maybe this VPN, and once I'll verify before you really get into the system, and once I verify, I'll trust you. So that has been the traditional security approach, and this is clearly not working actually. So people came up with zero, so everybody's talking about zero trust architecture, zero trust security nowadays, right? So essentially, it says, first, everything has an identity. So I as a user would have my identity or my workload, I'm running some image, that workload itself, that has its own identity, and which is made up of whatever, certain parameters that go into creating that identity, right? So all users, workloads, they have identity. You have very clearly defined policies. It's not just like free form text, right? So it's very clearly defined rules. You could have whatever structured format you want to follow. You have these rules which clearly state these resources can be given, these identities can be given these kinds of access controls on these kinds of resources. So, and whenever the access control is needed, that kind of access, every time you try to verify it. It's not again this verify once and then you're all done. So continuous verification is the key. Whatever happens, whenever something is activated, you need to verify it. So this zero trust approach, we sort of try to take this analogy to the software supply chain also. When we do that, the primary recommendation is to sign, attest, verify. So you sign your images, signed attestations, that will signed provenance records, signed vulnerability check reports. It could be bill of materials, or what are the my dependencies and their origins and so on. So everything here, you need to really sign all forms of code, configuration, anything that you have, so you essentially it's all about signing them properly, and all these biggies, right? NIST, CNCF, CIS, OWASP, they're really talking about that. And so essentially that's you do this and a large part of your problem is solved. Of course, still, of course, there are always caveats, but still it reduces the risk of your this software, make a reliability of your software supply chain. So there is this SALSA, right? So SLS is a different SALSA. Here, so software supply chain levels for, supply chain levels for software architects. So this is again the zero trust equivalent in the, software supply chain. So it's again talking about the same thing, right? Main thing is you have attested metadata for everything, right? So your image signatures, your provenance, I mean provenance as in what is the origin of your software. This is the GitHub SHA, this is whatever the specific commit, the review corresponding to that. This is the maybe whatever the command used to sort of do the build and so on. Vulnerability checks, you have all these tools now, right? So Trivi, others, you just ensure that, whatever you are building, you sort of do a vulnerability check on that. And this bill of materials. So essentially all this metadata, you club it together, make it available on the, along with the image that you're uploading on your registry. And finally, verify. So you have policy, you need a very solid mechanism on verifying your specific, defining your policies and ensuring that these policies are really, enforced, or at least there is some audit trail on that. So yeah, so there are multiple levels here. So you could start with just, just collecting this data. At least please, don't build on a developer machine and copy that artifact somewhere, right? So maybe that's the very basic hygiene. Hopefully, not too many people need to be convinced about that. Then collect all this metadata that we just talked about, right? Provenance, vulnerability, SBOM, just collect it. Then maybe go one level further, sign it. Yeah, you have collected it, but now you say that, yeah, I have collected. This is, I attest that, this is what the entire, artifact has been built with. Once you sign it, yeah, make this entire signed attestation available along with the image. So it's like you go a step further and finally you verify, so it's like, so SALSA levels, they start off, so you can start with one or a, mix of multiple levels, maybe 1 plus 2, some parts of 2, some parts of 3, and then slowly, try to move towards the final level. And yeah, so repeatability is certainly desired, but there are some interesting considerations there. I mean, it's like your, I don't know, people from the dev background, yeah, the functional equivalent, right? So you call it 100 times with the same inputs, it should give you the same results. But yeah, that's desired, but there are some, so getting to some of those advanced stages might take some time, it might not be always possible anyways. So let's just move ahead, yeah. So this is our original diagram, all these reds, just, convert them to green, add metadata. Maybe, GitHub, you could start with signing our commits. So generally, I don't know, not too many people use GPG keys to sign our GitHub commits. We just say our email address and that's about it. But, sign your commits. And all this, we'll see how to sign, create signed attestations for many different things, right? To be your build command, your environment, your SHA, the way you create your Docker registry, all that stuff. And yeah, even your dependencies, right? So sometimes, yeah, some, especially with Golang and all nowadays, I don't know, people who use Golang, about this go.sum and all that. So the SHA of the dependency itself is there in your in your Git. So that's a very, it's a very strong, measure in place, right? So maybe, others also slowly, I mean, we'll have all of those, things coming, all of those features coming to other platforms also, Java, etc. And then, yeah, finally we'll just look at some tools here. So, yeah, so all these tools, GPG signing, code signing, you have Trivi, GitHub Actions, you could have Tecton pipelines, and then, Sigstore has some really interesting software to sign images, to attest images, and A lot of work has also been done around, the format of these attestations. So intro to attestations, or the format in which the software bill of materials needs to go into the registry. So you have Cyclone DX for it. And then on the right hand side, we again, policies, I mean, we like Kyverno. So yeah, so Kyverno is there, of course, others also. And Kyverno internally works very closely with SIG-Store to co-sign SIG-Store to actually verify all this. So signing, verification, SIG-Store, Kyverno, all these, they really then, that's where they really shine out, and we'll see more about this. Yeah, we can.
Sure.
Yeah. So this next section again, let's so Swapnil take over.
I'll just take a minute to talk about the part where we see Kyverno written, right? So what Parikshit just mentioned is Kyverno works very well with the SIG-Store signing that is happening. For rest of the things, if you see as well, for the package part of it, there are some signings that we are able to do on the images using SIG-Store, and using the same capability with Kyverno, we are able to maybe verify them before we deploy them to the cluster, right? So I'll just give a brief view of what exactly does it look like when we actually deploy, or what exactly happens where now you've signed, you've attested, you've added your provenance, you've added your SBOM, and everything is there with you, right? So you have your image in your repository with all of this metadata. Now, without having something to verify this, you could still deploy this, right? I just have metadata with me. There has to be somebody who's going to come ahead and verify these things for me, and only then deploy or not, take a decision basically to deploy or not to deploy. So that's where I think one of the policy admissions is Kyverno is that we've used along with the cosign capabilities that it has. So that's what it does today. So I'll just quickly walk you through the 4 points that we have. This kind of explains not only the image signing and verification, but the entire workflow as well. So the first thing that anybody is going to do on the cluster is set up a policy, right? What this policy is going to be, it's going to be a YAML manifest that will have references towards all of these attestations or signings that we've done. Now that can depend on what kind of scanning tools that you've used, what kind of vulnerability checks you've done, right? What kind of SBOM has been, there are different formats that are available, which we just seen in the last slide as well. So to verify all of this, there has to be something on the other end to match this and then take a decision if we want to deploy this or not, right? So that's the first thing that we'll be doing on the cluster. On a Kubernetes cluster, I'll be setting up the policies. The admin is going to set up the policies. Second is, now for us to trigger this entire build pipeline, there is going to be a push that will be done eventually. So once this developer triggers a build, there's going to be a new image that will be created. But when this image is getting created, we'll just see how this happens in action in a minute. But what exactly it is going to do is, it's going to add some metadata to it when it comes up, right? It's going to do the attestations for exactly the things that I've mentioned here. It's going to be provenance data. What does provenance data look like, or what does it exactly is today is that it's going to have the exact details of the commit that has been done. In this example that we will show, we've used GitHub Actions, so it will give you the entire details of when was it done, who was the owner, what is the repository, and all of that data. So that's what we have in the provenance data, right? For vulnerability scan, we have Trivy that we will be using for all of the vulnerability checks that we'll be doing. And then SBOM, again, as Parikshit also mentioned, that's going to have details of all the packages and everything that goes in. So with this, with the image present here, it's pushed to the repository, and now it's ready for you to deploy this, right? Now, once it comes down, when it comes to the actually deployment of it, there is going to be this policy administration point, which is going to kick in again. And it's that point of time before even the image gets deployed as a pod, as a container, or anything that gets deployed on your cluster today. It's at that point, before it hits the API server, it's going to verify. Kyverno is going to help you verify all of these data that you've pushed with the metadata there and with the policy in action in an enforce mode that runs on your cluster. If and only if it matches to what it was at the source when it was pushed, only and only then it will help you deploy this image to the cluster. If even one of this attestation fails, it's going to halt, or it's going to stop you from deploying this particular resource onto the cluster. That's I think that's the key here that goes around for controlling or basically verifying all the attestations that we just did before it gets deployed to the cluster, making sure no vulnerable or no unwanted or no what you say in the security terms, that nothing that that has not been verified is going onto your cluster, right? So that's the part that goes there. So yeah, with that, we'll talk about, or we'll just walk through the demo, right? So for the demo, what we have is basically a sample pipeline that we have for GitHub Actions, as we talked about. So what this is going to do, if you see here clearly, it's going to build an image, it's going to scan the image for you, it's going to generate the SBOM, and lastly, it's going to sign the image attestations also. With this, we will have all of these data present as a metadata in the GitHub repository that we have, right? And we'll be, then let's move, maybe if we go to the next slide. So this is going to the policy that we'll be using, where it's going to check exactly the set of things that we've just pushed, or during the build that we used, it's going to verify all of this. Just quickly, I'll take a minute to talk about the keyless part of it, and then we see a list of attestations that we just talked about. Keyless is basically going to help you kind of verify things across the build tool that is being used. Today we are using GitHub Actions, so it actually uses a keyless verification. So it supports keyless verification where it takes the subject and the issuer. I mean, issuer is something that points towards the kind of build tool that we are using. And with the subject, it does a keyless authentication or verification for the additional extensions that we have. All of them together, we are going to be signing the image, so that whenever we are pulling the image, this is the first point of entry that is going to be verified. If your build is not verified with these entries that are present here, again, Kubernetes is going to kind of, this policy is going to restrict you from deploying the image to the cluster, right? And after that, we have set of attestations there. Now let's maybe show the action. I will just talk about the demo, and yeah, let's give you an example of the demo. I think, yeah, this is there. So you would see something green because we tested before the demo. That's why it's there. Now moving on. So what we're going to do is, I'm going to trigger a manual build here, which is going to just walk you through the steps that we have. So let's do that. Okay, I'm going to go here. I'm going to trigger a manual build for one. And let's say run workflow, right? It's going to take a minute or so. While that happens, what we're going to do is let's actually see what is happening here. So if you see, these are the things that it is going through. Now, while that goes through, let's open up the actual publish.yaml, or the GitHub Actions file that it is using, right? So I will give it to Parikshit, and he'll explain about what exactly the GitHub Actions is doing.
Yeah. So maybe I'll just open the equivalent one here. Let me just open this publish.yaml here. So here we see, so if you've used GitHub Actions, so it's pretty neat. There are a lot of interesting actions that people have shared, official ones and open source ones, and you could use those. So here we have this build image job, scan image job, generate SBOM job, and create attestations job. So all these, use various kinds of GitHub Actions. So this one builds, runs. This is a Java application. So runs Gradle, runs the Docker, Docker push, and even basically makes it available to this GHCR registry, and then. You have this the next thing is, it also generates provenance data. So it uses this Salsa framework extension. There are others also. So to build something called a provenance.json, then here you have this scan image step where you can see it uses Trivi, generate SBOM. For that also it uses something, there is this SBOM action. And then, ultimately it collects everything together, scan, SBOM, provenance, everything, and runs this interesting cosine sign, and it signs this image with certain annotations, and then it attests this cosine attest. And once this is done, the image is pushed to the GitHub repository, and it's available for policy verification. So just see, we'll now quickly look at a policy.
Right. Okay, so that's about the build. We'll just quickly see if it's done. It should be done by now. And what we will do, yeah, so if you see here, it's kind of completed, and there are some good metadata files or the details that it kind of gives us with all of these details here. With what we just saw, it kind of gives you the exact details that are required from maybe a provenance perspective, a SBOM perspective, and a scan.json perspective. Now these are exactly the metadata that are present at your image as well, and this is what is going to be verified at the policy end, which I'm going to show you in a minute now. So I will move on to that part of the demo, where now this is exactly the part where we've kind of pushed the image with all of this metadata and everything present in my repository, and now the part comes where I'm going to be verifying this against a policy and deploying it. I'm going to show you two scenarios. One is going to be a success one, and the second one where policy is asking for all of this data and the image does not have it, and it's probably, hopefully, it will block. So moving on, I'm going to quickly show you the demo for that. So let's check out the policy that we saw. I'm just going to quickly walk you through of how are we referencing it. So that's going to be my image reference. That's the image that I'm going to be verifying right now. Now this is again wildcard that can be added for specific images or an entire repository and what all is possible. So we can have that as well in the policy. Coming down, I have this keyless verification that I'm doing. Along with that, now attestation is something that I'll quickly spend a minute to talk about this. So this is basically verifying that the SBOM is going to be in my Cyclone DX format. That's what it is going to be verifying as a part of my policy verification. Second is, in the conditions, it's going to help me verify that this is actually scanned by Trivi. That's the first scan here that we see. Then coming down, it's going to verify that these scans were not done anywhere or anything before 240 hours. And coming down, it's again going to verify for the security vulnerability. So for in the SBOM, has all of your data regarding how Trivi scans it, and then has a list of all your vulnerabilities there. So what this policy is going to verify is that any given point of time, even if Trivi figures it out, there is a larger scan. If it is greater than 8.0, this is going to block the deployment of your resource if it has any vulnerability that is greater than 8.0 according to the Trivi scan report that comes out. And last, we have the provenance data that proving what is the GitHub actions and everything that we kind of walk through. So with that, let's just run this, where I'm going to be applying this policy to the cluster. It's as easy as just kubectl apply -f. That's a YAML file that I'm applying. Moving on, I'm going to be creating a deployment. Now, you would ask, what is this image that is present here, right? This is basically a deployment that I'm trying to do from the image that was built as a part of our build that we just did. And I'm going to then run it in a demo namespace, and let's just see what happens. So this kind of got deployed, right? It went through because of all the verifications that were a part of policy now. So that's basically a check that happens. Now, let's see what happens if I try to deploy something that is not relevant. So I've changed the tag of the image, right? Now this image has a different set of SBOM and different types of attestations being done. So if I deploy this, okay, that's something did not go. Okay, that's okay. I'm quickly going to verify what happens for the payload, and I also have something else for verification. I'll just quickly show the failure for this in a minute, but this is what exactly is covered as a part of our attestation. So if you see here, what is important is that it's taking this build sign attest part as the entry point, and there is this provenance SHA that comes up with the digest as well, the data that comes up for verification for us. So that's basically in the provenance part of it. And lastly, what I have is going to be the provenance data for rest of the things that we are kind of taking care of for the image that we just pushed, right? Let me just quickly, yeah. So if I deploy this is again a different image that sits in. Okay.
Yeah, so basically it's all the rules that we have given, right? So it tries to match the image. It applies only on the images that we have configured here, and then all the fields that we have configured in the attestation. So it will try to ensure that none of those fields have the attestations don't have something which is different from what has been configured in the policy. So this is what that, Red Hat score greater than 0.8.
Yeah, I think we can take up the
Yeah, anyways,
questions.
let's start with the questions. So essentially it will just block policies which, which don't adhere, which are not in sync with these attestations. So anyway, so let's start with the questions. We have 5 minutes left, and anything else, anything you would like to? Yeah. So most of, I mean, you all, so do you use some sort of attestation generation when the build pipelines are, when you have your build pipelines, or? Yes, I'd say I think it's time to start actually, trying some of these things out, and yes.
Yeah, Parikshit, I have a question.
Yeah.
Thanks for the details. Now, when that pipeline, whatever you defined, right? So you have any wrapper UI to do that, or like?
Oh no, this was the GitHub UI direct. This
That's
is
it,
the GitHub,
right?
yeah.
Okay. But you guys are using Kubernetes to come up with those policies.
Policies, yeah.
Okay.
So yeah, we'll right now this policy is a simple YAML. It's like our Kubernetes manifest.
Regular manifest.
Yeah, but yeah, we might as well have have some UI on, but actually it's because it's a YAML, UI is not very critical. Yeah, feel free to catch us outside. I mean, I think we'll be more than happy to discuss this.
Okay, thank you, Parikshit and
Thank you.
Swapnil, for the great talk. Yeah, you can find them out.